Hello, welcome back to my channel. I'm KCL, the previously mentioned electrical and electronics engineer from Bangladesh. Previously, in my last video, I mentioned about starting a playlist under engineering circuit analysis, specifically DC. You have been introduced to the elementary techniques of circuit analysis under direct current circuits, and going forward in this video, we are going to cover the topic of Kirchoff's current law, or KCL. So this is going to be a 20-minute long video where I explain what KCL is, who came up with it, how it is used, where it is used, and we're going to go through some direct problem solvings, which are going to be a recording of my computational device, and I'm going to explain it to you step by step as to how to use KCL to solve current problems in DC circuit loops, starting all the way from the simplest possible circuits all the way up to the more complex one. We're going to now move on to the screen recording. I hope you will join me. So I'm going to use Google Keep as my display board or my scratch pad, because let's face it, I don't have a better alternative, but this will work out. So Kirchoff's law is a law that was stated in use since 1865. 1845, stated or invented. I'm saying invented because actually it was discovered, because so whether somebody found it or not, the Kirchoff's current law existed as a property of how subatomic physics works. So discovered by German physicist Gustav Robert Kirchoff. He was a student in the University of Königsberg. University of Königsberg, while he was working on circuit theory, and it basically became the foundation for all later circuit theory. It states that in any point or junction in a circuit, the summation of electrical currents moving in and out will always be zero. That is, I1 is equal to I2 plus I3. Now, how this actually works out in a circuit is what I'm going to show. So let us assume that this is your circuit with a resistive load R1 here and another resistive load R2 here and another resistive load R3 here, right? If this is the case, with this being the positive terminal and this being the negative terminal, then what is happening here is there is a current called I1 here and a current called I2 here. Okay, and this I1 and I2 are basically the currents flowing through these loops, not exactly the currents flowing through each of the components, which are two different things. This can be labeled as I1 separately, this can be I2, and this can be I3. So what will result is the current that is flowing in as I1 will basically be the summation of I2, which is flowing through resistor 1, and I3, which is, let's say, flowing through R2 and R3. So for instance, let's say I1 is given as 3 and I2 is known as 1. We can reconfigure the foundational Kirchoff's current law to figure out that I3 equals to I1 minus I2, or 3 minus 1 equals to 2 amperes, which will basically become that the current flowing in is 3 amperes, the current flowing through these two circuits is 1 amperes, and the current flowing through here is 2 amperes. That's as simple as it goes. So the issue is, this is the first time I am using screen record, and I'm actually pretty uncomfortable. So I will create another video tomorrow and provide more examples, more detailed examples, as well as more complicated examples of how to use Kirchoff's current law to find the unknown values of current through any given circuit diagram. I hope you found it exploratory. I hope you found it interesting. Like, share, and subscribe. See you soon.